Hello grade 8 students, I hope that you are doing well. In this video we will explain the law of addition of voltages. Before we start, let us review the law of uniqueness of current. In a series connection, all the lamps are traversed by the same current, which means that the current remains constant. And we explained a rule with many examples. We said that the current across L1, lamp 1, is equal to the current across L2, is equal to the current across L3, is equal to the main current. So if you have one of the currents, you have them all since the current remains constant. Let's start with the law of addition of voltages. In a series connection, the voltage across the battery is equal to the sum of the voltages across all the electric appliances. To apply the rule, just follow consecutive points using the circuit. So the voltage across the battery is equal to the sum of the voltages across all the electric appliances. To apply the rule, just follow consecutive points using the circuit. So UPN, which is the battery, the voltage across the battery, is equal to UPA plus UAB plus UBC plus UCN. So here we started with UPA. We ended with the A. We start with the A here. UAB. We ended with the B. We start with the B here. UBC. Again, we ended with a C here. So we have to start with the C there. So it's UCN. Just follow the path of the current. So the current, as we said, flows from the positive terminal of the battery and gets back to the negative terminal of the battery. So let's follow the path of the current using the points. First we have PA, the voltage across PA, plus the voltage across AB, plus the voltage across BC, plus the voltage across CM. The sum of these voltages is equal to the voltage across the battery. Now, UPA is equal to 0. Why? If you look at the figure here, we don't have an electric appliance between P and A. So it's just a connecting wire. The voltage across a connecting wire is always 0. So this one is removed. UAB, we have the first lamp. We can't remove it. UBC, we have the second lamp. We can't remove it. UCN, again, we don't have an electric appliance here, so we have to remove it. It's equal to 0. So now we have a rule. The voltage across a connecting wire is always 0. UPA equals to 0Y since it's a connecting wire. UCN is equal to 0Y since it's a connecting wire. Another example, again, in a series connection, the voltage across the battery is equal to the sum of the voltages across all the electric appliances. To apply the rule, just follow consecutive points using the circuit. Here is the circuit. UPN, the voltage across the battery is equal to the sum of the voltages across all the electric appliances. First, we start with PA, UPA plus UAB plus UBC plus UCD plus UDN. We started with P, we ended with N. Okay? Now, we cross UPA out. Why? Since between these 2 points, we don't have an electric appliance, so it acts as a connecting wire. That's why it's equal to 0. The voltage across a connecting wire is equal to 0. UAB, I have the first lamp. It's an electric appliance. I cannot remove it. UBC, the second lamp. UCD, the third lamp. UDN, we will cross it out. Why? Since we don't have an electric appliance here, so it acts as a connecting wire. So it is a connecting wire. That's why we remove it. So we can sum it up, or we can summarize it as UPN is equal to UAB plus UBC plus UCD. Why did we cross UPA and UDN? Since they are connecting wires. The voltage across connecting wires is equal to 0 volts. Example 1. Referring to the figure, I have to calculate the voltage across the battery. So I have to calculate UPN. The voltage across the battery is UPN. I have to apply the law of addition of voltages by following the points in the circuit. So UPN is equal to UPA plus UAB plus UBC plus UCN. First, UPA is crossed out and UCN is crossed out. Why? Since they are connecting wires, the voltage across connecting wires is 0 volts. Now I have UAB plus UBC. The voltage across AB, or the voltage across the first lamp, is 4 volts. It's given. So instead of UAB, I can write 4 volts. And instead of UBC, I can write 3 volts. 4 plus 3 is equal to 7 volts. So the voltage across the battery is equal to the sum of the voltages across the electric appliance. Example 2. Referring to the figure, calculate UBC. I have to calculate the voltage across these 2 points, BC. What do we have between these 2 points? We have a lamp. So UBC means the voltage across the second lamp. The voltage of the battery is given. It's 12 volts. The voltage of the first lamp is given. It's 4 volts. So I have to calculate this one. Let's apply the rule. UPN, the voltage across the battery, is equal to UPA, follow the points, UPA plus UAB plus UBC plus UCN. UPA equals to 0Y since it's a connecting wire. UCN equals to 0Y since it's a connecting wire. So we have UPN is equal to UAB plus UBC. But here I have to calculate the voltage across UBC, the voltage across the second lamp. So UPN is equal to UAB plus UBC. UPN is given, UAB is given. I have to calculate UBC. So UBC is equal to UPN minus UAB equals to 12 volts minus 4 volts. So UBC equals to 8 volts. If you add 8 volts with the 4 volts, you will get the voltage across the battery. Example 3. Referring to the figure, calculate UAB. Now I have to calculate the voltage across the first lamp. The voltage of the battery is given. The voltage of the second lamp is also given. 16 volts, 6 volts. We apply the law of addition of voltages. UPN equals to UPA. Again, we follow the points. UPA plus UAB plus UBC plus UCN. UPA is crossed out. Why? Since it's a connecting wire. We don't have an electric appliance here. And UCN is also crossed out. Why? Since it's also a connecting wire. We don't have an electric appliance here. So it's equal to 0. We come up, or we end up with the UPN equals to UAB plus UBC. UAB, I have to calculate it, but UPN is given and UBC is given. So UAB is equal to UPN minus UBC. 16 volts minus 6 volts equals to 10 volts. If we add 10 plus 6, we will get the voltage across the battery. That's it for today, guys. Please, if you have any question, please don't hesitate to ask me, and don't forget to copy them on your copybooks. I hope to see you all very soon.